Okay, so let's learn about NoSQL injection. And specifically, we're going to be going from beginner, like what is NoSQL injection, to BSON injection, which is a relatively advanced item within MongoDB databases, which is a NoSQL database. So we're going to be going down to the weeds, but we're going to be doing it step by step. And this is actually we're going to have a couple of modules on NoSQL injection and they're going to be progressing. But right here, we're going to be kind of establishing a foundational just mental model of how injection works within the NoSQL sphere. So yeah, let's check it out. So all right, so what are we going to learn here? So what is NoSQL injection? Okay. Now also, how does NoSQL injection compare to SQL injection? And I promise this is not going to be boring. I'm not just going to regurgitate things that everyone else has said online. This is really going to help us establish that foundational model of just injection in general within databases. Now, we're also going to be evaluating MongoDB's claim that traditional SQL injection attacks are not a problem in MongoDB. So here's the thing. So we're gonna go through basically how they say that this isn't really an issue. Okay, just no SQL injection attacks is essentially what they're saying isn't a big issue in MongoDB, and we're just going to be we're going to be verifying that in some cases. So it's going to be a great exercise. Now, off of an extension of that, we're going to be evaluating how MongoDB can be exploited through BSON injection, and we're going to be learning about what BSON is coming up here. Now, and here is the foundational pillar of this talk, okay, is just understanding the execution context that queries are evaluated in and how those different execution contexts can be exploited. So we'll kind of see how you have one library that a developer might interact with, okay, and that they are passing untrusted input into. And then we see some of how that query goes down into some of the dependencies. And if there's an issue in some of those dependencies, how injection can occur. And that's really what the BSON item's about. So this is going to be great. We're going to go down the dependency rabbit hole. So, all right, so let's start. So what is NoSQL injection? Now, this is really introduced when developers create dynamic database queries that include user-supplied input, okay? Or in other words, it includes untrusted input. Now, what can this untrusted input, what can come a developer's way? Okay, so it can contain typical types like strings. Okay, so there can be some code in there or other items. It can have ints, or in other words, numbers, and some some things like that. Now, I mean, that are relatively standard. But here's the thing, there's also in the NoSQL world some things that can kind of come your way that have some different meanings than one would expect. So NoSQL can also contain query objects. So we're going to be looking at this injection through these query objects in another module. But we're also somebody can actually push out some binary to you or some hex or that it's encoded in hex, and we're going to see how that potentially can have some interesting ramifications in this one vulnerability with BSON. So there's all I'm saying here is that there's a bunch of different types that can come at you outside of the traditional items like strings, ints, etc. Now, okay, so, well, here's the thing. Let me just go back and clarify that a little bit. So somebody sent like evil hex your way, okay? It would be coming as a string. But the thing is just to my basically what I'm trying to illustrate here is that, I mean, it's not always just malicious code, like it's not just JavaScript or malicious JavaScript that's coming your way or something like that. It can be encoded in some different ways and have some pretty unintended consequences. Now, okay, so I just want to clarify myself. Now, okay, So why am I focusing on MongoDB? Well, here, I mean, it's really one of the most popular NoSQL databases there is. So learning about NoSQL injection, which is the query syntax that kind of interacts with Mongo. I mean, I think it's just kind of a no-brainer now because since MongoDB is really, it's just so established. Excuse me. Okay, so understanding the thought process of SQL injection will help us understand NoSQL injection. And here, that's why we are really going towards just foundational thinking. So let's look at an example SQL statement, okay? So select star, so select all from the accounts table where username is a username value and password value, okay? And these are coming directly from the username value and password value. And then the SQL statement is just executed, okay? And for those of you who aren't intimately, like really haven't explored SQL too much, you can kind of think of this as the accounts table is just where all the accounts are held, and username is basically just a variable, or not a variable, but rather just an item within it, and also passwords are an item within it, and then every single user has values there. Okay, so we go ahead and this statement is vulnerable to SQL injection. And we go ahead and just pass that SQL statement into query. Now, when SQL statement is passed to query as a string, what functionality does this inhibit? So just kind of think about it just a little bit. What is this? How does this like what is this doing kind of behind the scenes, and could there be any unintended items from this? Now I will continue. Now here's kind of the thing here. So query when it basically when SQL statement comes in, it's just a blob as a string, okay? And so query has no way to scope username value to username. Now, what could be the problem of this? So just kind of think about it for a sec. Now I'll continue. I'm sorry, having a little throat problems. Of course, it's always got to occur right when you're doing a tutorial. Okay, but you'll bear with me. All right, so now, okay, so what are some of the problems? Now, as username value is not scoped to username, it can affect the meaning of other items that come after it, and it can change the query. So let's check this out. So imagine what would happen if the username value was this. Kind of think about that in your head. What would that do? Now, the resulting SQL statement looks like this, okay? So we basically what happened here is that the user passed in a single quote, and this single quote is terminating basically the end of the username, okay, in the eyes of SQL. And then these little double hyphens right here are passed in, which is the comment syntax. So everything after that is then ignored. So basically this person right here, if could log in as admin if this SQL statement was the validation for logging in. It can get really bad. But now we're taking this knowledge and starting to apply it into a MongoDB like query syntax. Now, in MongoDB, typically when devs interact with it, this item up here, all this SQL, basically would have a counterpart as you would see down here. So we're querying an accounts collection instead of a table, and then we're finding username value and password value. So I think obviously you get that. But the thing here to kind of think about is it really looks like username value is scoped to username. So could username value somehow bust out of this context and somehow just comment out the password item, kind of like the SQL statement did? I mean, on face value, it doesn't look like it can. It looks like it's scoped or mapped directly in. So username value is mapped into username and it cannot bust out of that context. Now, that's then the question with this is really so okay, so is username value injectable in the same way in a way sort of as the SQL statement, okay? Now, MongoDB has a statement on these types of attacks, and this is what they say. Well, before we get into what exactly they say, they're going to be bringing up this thing called BSON. And what is BSON? Really, MongoDB represents queries as BSON objects, and BSON is just binary JSON. So way down under the hood, instead of literally, you know, b- basically JSON gets serialized into like a binary format, and then that query is then executed in that format. So that's basically what happens under the hood. So this is when I have these little quotes here. That's just kind of this is basically coming from MongoDB because they have an item on their website that talks about basically how I mean how MongoDB isn't really vulnerable to SQL-like injection attacks. So anyhow, we'll get to that quote, but let's kind of continue. So Mongo says typically client libraries provide a convenient injection-free process to build these BSON objects. And they basically say consider the following C++ example. So I kind of altered this to fit within the format of the query that we just saw, okay? And I just took out the password stuff just for simplicity. So we see the BSON object being created right here. Okay, so username value comes in, then we have username. It constructs a BSON object called myQuery, and then myQuery is happens is basically executed against the accounts collection. Sorry, sorry that the selection kind of got goofy there. Anyhow, okay, so this is what Mongo further they keep kind of going, and they say as a client program assembles a query in MongoDB, it builds a BSON object, not a string. Thus, traditional SQL injection attacks are not a problem. And when they are talking about a client program, like right here, basically they're just talking about they're essentially talking about this, like this syntax that is used by the developer. Really kind of like at the top of everything. It's just kind of the entry point into querying MongoDB, okay? Because there's different kind of client, applications, either in Node or in Ruby that we will see very shortly that kind of, yeah, do all this assembly, okay? So, interesting. So they say this is a bold statement. Thus, traditional SQL injection attacks are not a problem. So if I was a brand new developer, okay, and I didn't really have a lot of security knowledge or whatnot, I would be like, oh, well, it would be okay for me just to pass untrusted input, into, basically into username value right here because, hey, traditional SQL injection attacks are not a problem. Now, I don't really know, I mean, they kind of say this little qualifier here, traditional, but it's kind of hinting at the fact that SQL injection attacks just really aren't a problem. And so when we say SQL injection attacks, yes, it's technically NoSQL injection, but they're just kind of making a parallel here between NoSQL injection and SQL injection. Basically, they're just saying any kind of query injection or typical query injection attacks are not a problem. In a nutshell, is what they are saying. All right, okay, sweet. Okay, so now, okay, so we saw this. Now here they basically continue to say this. Now, if my query contained special characters, okay, for example, say like the comma and some other items that are typical within a JSON object, okay, the query wouldn't match any documents. So they are basically saying, okay, so let's just say somebody was trying to bust out of this username kind of context and do some other items by appending some special characters in there that are particular to JSON objects. Basically, they say since my query is directly, well, they say this. The user would not match any documents, and the reason why is just because basically my query, this username value is directly scoped to username within my query. So that's why basically no other objects. When my query is executed against the accounts collection, no, it wouldn't find any objects because these special characters would just be interpreted literally. They wouldn't have any special meaning within the BSON execution context. All right, so I know it's a lot, but we're getting to a pretty cool exploit with BSON, and it's going to kind of show that some of these, eh, what appears on the surface, like, hey, I mean, everything's fine, that there could be some ramifications. Yeah, could be some negative items. So, anyways. This is kind of a similar thing. So basically, what they're saying here with these special characters, this is essentially analogous to the special characters within the SQL statement that we saw, which were just the single quote and the hyphens. Okay, so all right, now here's the thing. Okay, so Mongo's statement about the lack of injection vulnerabilities assumes the input will be passed in a certain way. Now, what is that input assumption? Okay, that's going to be passed in as a string. Now, let's check this out, and we're going to be looking at basically how a string could potentially exploit this BSON query object. So let's just say that this was our initial, these were the items that we are querying on. So we had a username admin. Now, under the scenes, what is constructed is the field name, okay, so username gets input right here, and then the field value is down here, okay, and you can notice there's some special characters, okay, like this guy, this hex right here, which is then basically converted to binary. But anyhow, this hex is an end of object. So just kind of notice that there are similar delimiters within BSON, right? So you kind of start seeing parallels here. Now, okay, so here's the thing. So how could a string potentially exploit this BSON object? Okay, now here's the thing. So it can insert a BSON special character or a delimiter, right? Like just right here. Now, and this is the same kind of similar idea with the single quote with inside username value that was able to bust out of that one context, and basically right after that, it was able to comment out the rest of the SQL statement. Now, here's another thing. Another potential vector. Now, I'm just saying potential. These aren't things that, I mean, would necessarily work, but this is just kind of if you're putting on your attacker hat and just thinking about when you see somebody say something like, oh, well, traditional attacks here, kind of traditional SQL kind of, injection attacks aren't really possible. Well, okay, well, it kind of would lead one to believe that, I mean, you're fine just to put untrusted input in there. But it's like, when you kind of put on the attacker hat and you think about ways that things can be exploited, you kind of start kind of checking off some boxes in your head. So the next box is could someone insert BSON directly in here? Okay, so for example, right here where there is that this admin value, right? Could this be a whole BSON object directly in there that maybe had some other kind of query manifestation? Okay, so that's another potential way that it could occur. Or what's if somebody would just insert hex or just binary just directly in here? What would happen then? Okay. Now, here is a really, really interesting item, and it's basically this. What's if somebody inserted garbage in here that wasn't BSON and then caused a denial of service? Now, we're going to be looking at how that actually could occur within an old vulnerability within basically this. Yeah, well, I'm not. We'll just get into it. I don't. I want to show you the physical example first. All right, so it's the vulnerability within BSON Ruby. Okay, so let's kind of get into BSON Ruby and like what the background is. Now, kind of this is BSON Ruby is like it's kind of a lower level dependency. So let's kind of start at the top of the dependency tree and kind of work our way down. So okay, it all starts with Mongoid, and that is a Ruby ODM, or an object document mapper for MongoDB. So that's the thing. So like a developer, we kind of saw that Mongo query syntax before. It would be a similar type of syntax, but it would just be in Ruby, okay? And they would leverage Mongoid to execute queries. Now, Mongoid leverages a lower level adapter as one of its dependencies called Moped. And then Moped leveraged another dependency called BSON Ruby. Now, okay, so that's one item, and we're going to kind of see a vulnerability within this BSON Ruby class, or BSON Ruby dependency. But before we get there, we need to have a little bit of some background on Ruby regexes. Now, okay, so in a Ruby regular expression, okay, these items, okay, right here, basically match the start and the end of a string. But these items right here match the start and end of a line. So, okay, well, what's the difference there? Well, basically, this $ matches a new line character. So, where you can think of this item up here matches the complete string, this only matches up to a new line character, and there might be more items within the actual string after it. Okay, so think about validation logic. If somebody put this in there, okay, and thought that it was validating a complete string, but it was only actually maybe validating a quarter of it because somebody put a malicious new line in there, and it said, oh, this passes validation, and it actually there was a bunch of other bad things within the string that came after the new line. Some bad items could happen. Okay, so in other words, this is basically a way of just getting injection. Okay, so but here is the confusing part and why it's kind of hard within Ruby for some individuals. And it's because other languages, this basically this $ matches the end of a string. Okay, so some developers can kind of get this flip-flopped, and it can cause some vulnerabilities. This actually, a variation of this this idea actually resulted in some code execution on GitHub, some XSS vulnerabilities. So yeah. Now, what we are going to be looking at is an issue in the wild, and you can click on the in the show notes this link right here, and it'll show you the commit where this happened. But basically, there's this interaction with this this Ruby regex within BSON Ruby that could cause some pretty nasty things. All right, so let's see the validation logic that BSON Ruby was doing. So, and this is the vulnerable implementation. So, okay, so let's just kind of back up a second. So, a developer, let's just assume that a developer is placing untrusted input into the creation of a Mongo object ID. Okay, so they're putting that in there, and then within BSON Ruby, way down the dependency rabbit hole, it's checking if it's legal, okay? If what the input is legal, and it's basically looking is, hey, it's determining if the provided string is a legal object ID, or in other words, it is a hex string. So, but here is that vulnerable regex, okay? Now, let's see some unintended consequences of like what could happen here. Now, um, okay, so let's just say that we have this well, before I even get there, I just want to give a little shout out here to Igor. This man created all this research, and I'm really thankful because we get to explore it together. But okay, so in Igor's proof of concept, he basically showed that if a string that was passed in, all right, from say some untrusted source, and it contained this. So this would be 24 A's, which would pass the basically the hex string part of the validation. And then there was an added new line character. Well, this is not hex, right? This new line character is not hex, and this would go through and it would pass this validation and it would get inserted into Mongo. And why is that? Because the developer probably thought, oh, this is just matching the end of the string, but this is actually matching a new line character, which is not supposed to be in there. So Igor said within his research that when this occurred, basically Mongo, it just created a denial of service condition, and Mongoid was not able to talk to Mongo for a little while after. So there could be some really some bad stuff there. Okay. Now, and here's the other vector is just pure injection. So basically what is going on is here's that new line, and then so this right here would go through and it would pass validation, and then the attacker could put arbitrary hex after that and do some other items. So go into Igor's research and you can kind of dive a little bit deeper, but this just shows us, right, that you know what? I mean, things that might appear to not be injectable are, okay? And I know that yes, this was an edge case, and it was kind of like, hey, this was a problem within some validation logic within BSON Ruby, but anyhow, I'm bringing this up because a lot of people could see Mongo's statement and kind of think, oh, well, I'm okay. But we always need to do input validation. We always, and I would assume that Mongo would say that as well. You need to do input validation before any of your queries get fired off. But I just really wanted to drill it home, and hopefully all of these items that you are seeing here with how a query can then go down into all these different contexts and how there could be vulnerabilities way down the dependency tree. I hope that this is helpful for you to understand NoSQL injection or just injection in general at a really fundamental level. So, okay, so here are some takeaways. So, like I was saying, contrary to what organizations say or could kind of hint at, injection is always a risk when you take into account all contexts that a query is evaluated in. Now, in the next module, we're basically going to be doing a hands-on exercise where you will inject a query object. So here, this was more of injecting BSON and whatnot, and kind of like exploiting that. But here we're really going to be, in the next module, we're going to be kind of injecting in a query object and kind of seeing some of the ramifications of that. So cool. I'm looking forward to seeing you then. All right. Bye bye.